Now good morning my dear students. Now in this process management system, today we are going to discuss few more steps that how these processes are evaluated in the computer system. Now in this process management, first topic, process management. In this, when a process needs to be executed, it approaches OS, the process scheduler. Means when any work is there, that process will come to the process scheduler. Then after a process is given some memory with this, means it will be kept somewhere in the memory, in the RAM, and according to that it will be evaluated. Now the first is the region in the memory holds the compiled code, and one section will be there. In that compiled codes will be kept there. The next region in the memory area where the global variables of the programs will be there, means that program will be segregated in separate parts. In one part program will be there, in other part that compiled codes will be kept, and in one section all the variables that we have used, that will be kept in that tabular form. Now in the next, the stack is used for holding the return address at function call, argument passed to the functions, and local variables for the functions. So whenever we are giving any instructions to this program, and instruction means we have written the code, so that program will take input from the user also, and that program will give some outputs, will return some output in separate forms. It may be string, it may be number, it may be float. So according to the return, stack will be created, and it will confirm that in which section, in which sub program it is connected. If it is connected, then it will take the value from the other section, and then after it will rejoin and give the value. Now the next is the heap memory area is a region of free memory from which chunks of memory are allocated via process dynamic memory functions. Means if any memory is needed at runtime, and if you have given any function to take the value at runtime, then this dynamic memory will be allocated. Now in this process management, means how this program is going on, there are stages. The first is start state. Start state means if a program is ready to go inside the memory for its execution, this is called start state. Next is your ready state. If the program is ready for its execution inside the memory, then it is called ready state. Next is in running state. Running state means if the program is running inside the memory, then it is called running state. Then after waiting state, waiting state means if more than two programs, number of programs are running in the memory, then it has to wait according to the input output conditions. If a program needs some input from the user, then it will wait. So this is called waiting state. Then second is terminated. Terminated or exit. After execution, that program has to come out from the memory, so this is called terminated or exit state. So basically we have just separated the running of a process in separate stages. If a program is running, if a process is there, then it will start. Start means it is it has to be performed. Then ready state, now with all the variables and all other linkings, it is ready to run. then after it is going inside the memory and it is running. Then after waiting, if there is any input output condition, then it will wait for some time, and terminated means after execution it will come out of the memory with the result that we want. Then after, for running any program, for processing any system, we must allocate some memory and some IDs, because we know that if there are so many number of thousands program may be there in the RAM at one time. So how the computer will segregate in all the systems? So first is it will provide process ID. Process ID is what? Means every program which is running inside the memory must have some name so that it can be rectified from the others. Then after, process state. Process state means it is waiting, it is running, it is terminated or what. So everything operating system must know, so that it can identify the processor's idle time. Means if 1000 programs are there, it has to be in line and it has to come one by one. If operating system will not keep record of all the processes which is coming, then it will be a idle time for the processor will not get the work one after another. It is the major role of the operating system that our processor must not be free. If it is not free, then our performance will be high, our performance will increase. The next is process privilege. Process no sorry this is our PCB. This is the most important thing, that processor privilege is not the important thing. This PCB, this is our process control block. As we have discussed process ID and process state, all these functions will be stored, will be kept in this PCB, process control block. This is the this block is like stack, means like one or above the another it is kept, and we can simply hold the processes which is running at that time in this process control block. This is the important thing. Now the next is our pointer. What is pointer? A process can create sub processes. This is the pointer. For example, if we are running a game, so how it will create the sub processes? In a game, you know that if you are starting the game, then sound will be there, graphics will change, if some kind of output, then it will come, or you can give the input through mouse or keyboard also. So there are so many processes which is going on with one program. So one program is creating many other systems. So this is the pointers. The next, our program counter. Program counter means the next instruction to be executed for this process will be present before the termination of the first. Means if any program is running, then it will not be finished and CPU will not wait for the next. As it is running, second process will wait before its execution, so that it will reduce the idle time of the processor. The next is your CPU registers. CPU registers, it stores the information about CPU registers which the process can be used for execution. So CPU registers is the memory block in which the basic instructions which is needed for the execution of our program, that will be kept. This is called CPU registers. And others, scheduling and accounting informations, like how long it is how much time it will take, all these things will be kept side by side. So these are the some major points in this. Now how the CPU how CPU executes the instruction of a ready process means, if a process is ready, then how it will be executed by the processor. Now the first is program is loaded in the main memory. Now this is for the process which is ready. So first it will be sent in the main memory. Then second point, control unit brings first instruction of the program, fetch the instruction. So according to the program, our CU control unit will fetch the instruction that what type of program it is and how it will be executed, what will be the output. Now CU now determines what type of instruction is this. CU will determine that what type of program it is that we have to execute. Is it a mathematical work? Is it a logical work? Is it a simple memory input output, or is it a simple output, means one has given paint program and some output he or she wants. So this will be identified by the CU. Now if the instruction involves mathematical or logical work, CU instructs ALU carry out or execute the instructions. Means if everything is correct, then CU will send the instruction to ALU to evaluate it, that how much time it will take and what will be happening in the calculation part. Now ALU produces some result and stored in the memory. So as the ALU will produce the result, according to that CU will start sustaining the process. Now this was the way by which a process is evaluated, is executed in the main memory. Now how it is scheduled. Process scheduling by OS. Now we have seen that how it is evaluated, how it is executed in the main memory in the computer system. Now how it is scheduled, now which program will it be executed first, which has to wait, what should be the waiting time, everything will be evaluated by this process scheduling. Now it will do the certain works like which process will get the CPU time, which process has to be removed from the CPU, which process has to be shifted for input output, and what is to be in the case of interrupt occurs. Means all these points will be considered by the process scheduling. What is interrupt? One word as it is, that's I coined one word. Interrupt is the instruction which will raise the hand, means it will stop the process. It may be from the hardware or it may be from the software part. So basically interrupt occurs when any system get confusion through the input or output what is going on. Now there are certain mechanisms through which it will be calculated. FCFS. This is first come first serve. Means as the process will come first process will get the time first, and then after second process will get the time. Then next is round robin. Round robin scheduling. Round robin means every process will get some time, and within that time it has to be evaluated. In round robin all the processes will get the equal amount of time, and with that equal amount of time every process will try to complete its work. If any process is unable to complete its work, it has to wait for its next time. This is called round robin scheduling. The next is your SJN. This is the shortest job next, means the process which is very small, that will come first. If the process is large, then it has to wait for some time. As the smallest process is executed, then only the biggest process will come. So this is these three different mechanisms in FCFS. First process will be executed first, then after the second, then after the third. In round robin, every process will get the time, and in that time it has to be completed. If it is not complete, then it has to wait for the next turn. SJN, shortest job next. Processor will evaluate that which process is the shortest process, and according to its evaluation, uh, the processes will be evaluated. Processes will be evaluated. Now next is, in this process scheduling, processor will try to keep everything in a line, that which process will come after which process. So this has to be done to reduce the idle time of the CPU. In this job queue, one more point, it is job queue. What is job queue? This is the line in which all the processes are kept with their process ID. The next is your ready queue. Ready queue is the queue in which all the processes are kept with the algorithm. Means it will be evaluated with FCFS. Your operating system is going to evaluate it with SJN or round robin, which logic your operating system has applied. After application, ready queue is formed. Next is device queue. Device queue is the line in which process wants which type of device. Means if any output is there, so output may be different types, sound, visual, or on hard copy may be there. So which type of output it's required, that kind of line will be formed by the operating system, and it will be sent to that part. So this is the device queue. Now the third most important thing is your memory management. Memory management. Now in this memory management, we will not talk about the hard disk. We have to consider only the RAM, because a hard disk is not the internal memory. This is basically not used while execution of any kind of program. So what is the memory the memory manager performs these functions, keeps track of each of the memory location, regardless of either it is allocated to some process or it is free. So it will keep eye on the memory location where it is free or it is allocated, checks how much memory it is allocated to process and how it is allocated. It will keep record that how much memory is taken by which process, decides which process will get memory at what time. It will decide that which process will get the memory at what time it will be given to that process. Means every process will not get the memory at all the times, so it has to take the memory and it has to complete its work and then go. Keeps track of whenever some memory gets freed or unallocated. Means if it is free or unallocated, then that will be also in the under this consideration of this operating system. Ensures the safety of data in the memory allocated to the process, so that other running processes do not get hold of this data. It will keep the safety of data. Means if any process comes inside the memory, it should not last long there, it should not stay there, it has to complete its work and then go. Now in this memory allocation, contiguous and non-contiguous memory is allocated through the operating system. Contiguous memory means if 200 MB of RAM a program is needed, so 200 MB is given directly. If our operating system is logically it is applying that we are not having that much amount of memory, so what it will do, it will give the 200 MB but from separate parts, 100 from this, 50 from this and 50 from this. So this is managed by the memory management. Now single memory allocation, this is the memory allocation in which at one place the chunk of memory is given. Second is your partitioned allocation, the same that I have explained, means memory will be given but some will be from this part, some will be from that part, and you will get the chunks of memory. Then paged memory management. Paged memory means small uh, pages of memory will be there, and in a small pages of memory you will get the memory management of the memory which you are having. The segmented memory management, in this the memory is divided into the logical unit called segment. So if the memory is divided in logical units, then it is called a segment. Logical units means if any game is there and in that game you are performing the sound section and the virtual section also, so logically it will be divided and logically it will work, so at that time it is called the logical unit of that section, game section. Then the last is our input output management. Input output management will keep the eyes on that how you are giving the value and how you are taking the output from the computer system. So in input output management, the input output manager sends the input output request to the physical device, and upon receiving the response from the device, it passes the received response from the processor to the respective drive. So this is called input output management. Now in input output management there may be different sections, that we can take the input from camera, from mic, or from keyboard, or from mouse. So how we are taking the input, this is the main thing, and we are transferring that data, this will be done by the input output manager. Then after parallel computing, what do you mean by parallel computing? If processors are shareable, or if we have joined many computers all together, then this is called parallel computing. Means if any one computer is having many different processors in it, or we have connected the computers with the help of LAN wires, so this is called parallel computing. Now a program is broken into the discrete but independent parts that can run simultaneously without depending upon others. This is the first point which the parallel computing will perform. Means your big program will be broken down in small programs, and it will be evaluated through different processors. So what will happen, all the processors can do the work, and it will be in very small time it will be complete. Then next is each part has its own instructions that can be executed independently. Now if many processors are there and all the processors are getting its work with it, then definitely all the processors will have its different work and its different responsibility to complete the work. Then after, instructions from each part execute simultaneously on different processors. Instructions will be evaluated and it will be completed by the separate processors, and it is a separate work. So this parallel computer will reduce the idle time, or it will increase the efficiency of the system. Then what are the advantages of the parallel computings? It saves time and the cost also. It makes it easier to solve larger or the complex programs. Many problems are so large and or complex that it is impractical or impossible to solve them on a single computer. It provides efficient way of underlying hardware. It can utilize the resources available remotely. So all these are the advantages of this parallel computing. Now students, next is our cloud computing. Basically, cloud refers to the system in which we are using internet to save the data. This is the most widely used technology nowadays, because we are not keeping everything in our system in our hard disk. We are storing the things in the uh, on the cloud, means internet. So how it is working? No cloud is of individual. Nobody will hold the cloud for its personal use. There are two types of cloud. One is public and one is private. Public and private cloud. Now, cloud computing refers to storing and accessing data programs over the internet instead of your computer's hard disk. The first is your public cloud. Public cloud is owned by the third party, and in this third party cloud computing, it will give the services only. You have to maintain your login ID and password, and you will just access your data by sending your login IDs and passwords, like email services or any other, like Azure, Google Drive, Amazon Cloud, iCloud. All these are public clouds, means nobody will have its personal access. And what is private cloud? Private cloud is used by any company, and like any railway reservation system, or the SBI, State Bank of India. So these are the private cloud that will be maintained by the company itself. It will not be maintained by any third party. So this is called private cloud. Now students, this fourth lesson is complete, and tomorrow I will discuss question answers of this lesson. Thank you.